Hello all, welcome to the next video on NFA. NFA is similar to DFA because it is a finite automata which will not produce an output. It will either accept or reject the string. So now it has no memory, no output, and it consists of states and transition among the states just like DFA. So here is a sample NFA. Here Q0, Q1, Q2 are the states and 0 and 1 are the input which is given to the states. And here you can note NFA will accept any transition like this, unlike DFA. DFA will not accept a transition like this, like one state it is accepting the same input and it is moving to two different states. This is not possible in DFA. The same thing is represented with a self loop here also. Here it is accepting the input A and it is moving to itself, and it is accepting A and it is going to a different state. So this is also a kind of accepting same input and moving to two different states. Both are acceptable in NFA, which is not accepted in DFA. So the tuple notation, it is similar to NFA, DFA, that is Q, epsilon, del, Q naught and F. Q is the set of Q represents set of states, the states which are in the NFA model. So here it is Q naught, Q1 and Q2. Q naught, Q1 and Q2. And sigma represents the input 0 and 1. Del is the transition among the state, so which is Q, the current state when it accepts an input. What will be the next state? That is Q into sigma is equal to Q. And then Q naught represents the starting state. Here Q naught is the starting state and Q2 is the final state. Q2 is the final state. So the transition function del is also same, just like DFA. So it is current state comma input will give you the next state. For example, del of Q naught comma 0, it is moving to the next state as Q naught itself, and del of Q naught comma 1 is also moving to the next state as Q1, and del of Q naught comma 0, actually it is moving to Q1 here. It is going to Q naught and Q1 here. So you can represent it like this, Q naught, Q1. And Q1 on receiving an input 0, it moves to Q2. And Q2 has no transition, so we can leave it or you can give it as null. Moving on to NFA construction, here is an example. Construct an NFA to accept strings of zeros and ones that end with 00. So first identify the language as you do in DFA. So L is equal to that. Here it is the one which ends with 00. So 00. Before that you can have any combination of zeros and ones. So the basic string will be 00 and then 1 0 0 0 0 0 0 0 0 0 0 0 0 1 0 0 and it goes on. So the basic string is 0 0. So you'll have the number of symbols plus 1, that is 2 plus 1 states. So here it will be 3 states in the transition diagram. So Q0, Q1, Q2. So the basic string which is accepted is 0 0. So before this, you can have any number of zeros and ones. This is possible in NFA. That is, this self loop is possible in NFA because NFA accepts one input and multiple state transition. Moving on to the transition table. Transition table. So this is the current state, and next state with inputs 0 and 1. So write down all the states which is involved: Q0, Q1, Q2, Q1, Q0 being the starting state, and Q1, Q2 being the final state. Q0 on receiving 0, it moves to Q0 itself. Q0 on receiving 1, it is moving to itself. Q1 and again Q0 on receiving 0, it is moving to Q1. So give it in parenthesis. Q1 on receiving 0, it is moving to Q2. And there is no transition for 1. And Q2 is having no transition at all. Now listing down the 5 tuples, NFA is equal to Q0, Q1, Q2, which represents Q, and 0, 1, which represents input, transition del, and Q0 is the starting state and Q2 is the final state. So a list of transition functions. So del of Q0, 0, that is current state, and input is equal to the next state. So here it is Q0, Q1, and del of Q0, 1, the next state is Q0. So the next state is Q0. Either you can see the diagram or the table. Q1, 0 is equal to Q2. Del of Q1, 1 is pi. Del of Q2, 0 is pi, and del of Q2, 0 is 1 is also pi. So this is the problems how you can solve it with NFA. So NFA it is giving you more flexibility than DFA. Thank you.